So welcome back, everyone. We are resuming with the Alain Fournier Dissertation Award talk. Pierre Pauline will be giving a brief introduction for the awardee this year.
Hi, so let me introduce to you Maria Shugrina. She is the winner of the 2020 Alain Fournier PhD Dissertation Award for her thesis entitled The Design of Playful and Intelligent Creative Tools. Her work combines artistic insight, she's an active painter, and AI to create new interactive color tools for artistic expressions. She has published the graphics part of her work at SIGGRAPH, the vision part at CVPR, and the HCI part at CHI. She received her PhD in computer science from the University of Toronto under the supervision of Karen Singh and Sanja Fiedler. Congratulations, Masha. So the Zoom bandwidth is now all yours.
Thank you so much. I'm delighted to be here and present my work. Really grateful. Let me jump into it since there's not that much time. Creativity is not a niche application. From the earliest years, our ability to create things has been the defining characteristic of human society. And today, in the digital age, creativity expands to more and more applications that didn't exist before. For example, computer programming and animation. And we also have an unprecedented ability to use digital technology to craft our own creative media. So personal motivation for me is that I have failed to find the same satisfaction while using digital painting tools as I do when using a paintbrush. I don't know exactly why, but when I'm putting paint on the canvas, I forget that the world exists and I'm transported into this completely different experience. It's not necessarily more efficient, but I love doing this. So the question I ask in my research is, how do we build tools that can be loved? So while traditional media impose intuitive rules by its very nature, and it can also be constraining rules, digital media makes virtually anything possible. So how does one go about designing when anything is possible? In a common approach, the focus is on the final result of the creative activity. And the aim is to design interactions that will enable achieving that result in the most efficient way possible. So it's very goal-oriented. But it's hard to imagine a new generation of tools without some sort of artificial intelligence component. So much of the modern research focuses on developing intelligence that is able to somehow support creativity. And an emerging class of research, users can also interact with intelligent agents to some extent in order to control the result. But in much of this work, interaction is a bit of an afterthought, though that is starting to change, and that is really great. So in this picture, are we perhaps forgetting something? The creator herself is an essential part of creativity, and it's useful to be reminded that making something is not a straight path from A to B, but the experience of the creator is essential in fostering creation as a process, which is nonlinear. So in my work on designing for creativity, I focus not only on the usability of tools that I make, but on the enjoyment of the creator by designing intuitive, expressive interactions augmented with some domain and artificial intelligence with direct control in order to fuel playful exploration. But design is a practical pursuit, so of course I have to try designing interfaces for specific applications. Much of this talk is about color. This first project is in collaboration with Jingwan or Cynthia from Adobe Research and Steve from Adobe Research. And it concerns with a palette. Traditionally, a palette is a wooden slab that artists use to mix colors and organize them for their artwork. So we observed that while digital brushes have made remarkable progress over the years, digital color tools largely remain the same. Of course, there are many exceptions, and you should look into the paper for details. In order to understand how painters use a traditional palette, we actually watched traditional artists interacting with the palette, and we recorded them. We analyzed these interactions, but more importantly, actually, this became a really strong inspiration for the design. So this is what a palette may look like after just 15 minutes of painting. It's expressive, unhindered, there's no constraints, you can really play around there, but also it's messy, you can't reorganize it, you can lose colors. So because we can do anything digitally, we don't have to import these negative properties of the palette into the digital domain. We can literally design anything. So we came up with an interface that allows artists to mix these blobs of color to create custom blends, but they can just as easily unmix them. So it's non-destructive. And with just a few blobs, it's possible to construct rich custom manifolds that can be then used to quickly access colors during painting. For example, when painting this fish, I can construct a color manifold that's well suited to what I envision, and then I pick colors from this mixing dish without having to work with sliders or HSV or anything like that. And all of the painting dishes that I create are saved for me completely automatically because we can do these magic things digitally. And so this really allows you to play around with color. So for this project, we received very positive feedback from our user study participants, and there was really nice reception for it in the press. And I presented it at Adobe Max in front of all these thousands of people, and people on YouTube kept asking when it will be released, but it never made it into a product. And I'm still asking myself, well, what could I have done differently? But in a sense, this is a failure. But I guess this is what inevitably happens when you try to design something new, and we still have to try because our interfaces will really, really change, I believe, in the next few decades. So when I came to U of T, my goal was to try and actually build something that I could put into the real world. So this next project is in collaboration with Wenja, Fanny, and of course, Sanya and Karan, my supervisors. So color is everywhere. And the choices we make for color make a really strong, have a strong effect on the perception, communication, and so on. With Playful Palette, I focused on painting, which necessitated putting this widget in a digital painting application. So with the next project, I thought, well, can I build something that's useful across domains? And designing a palette separately from a piece of artwork can be very useful. For example, these few colors can be reused across many screens designed for an application. And designing and sharing palettes is a common use case, and there are all these websites where people do this. And most often it's represented as a few solid color swatches, which is nice and simple, but also a bit limited and fails to capture common design use cases such as discrete gradients and smooth gradients and even 3-color blends. So if I'm designing a color palette and I want the colors to be used in a design that has gradients, I can't very easily get a sense for what these colors are going to do. So I have to jump back between my graphic design applications and palette design. Because I need to visualize the gradients. So with this project, we designed an interface that allows you to think about color choices while having access to these tools. And it supports discrete swatches, smooth gradients, step gradients, and also 3-color blends in the same interface. The inspiration for this is designers' mood boards and children's play. And the interface is a playground. So because it's actually online, I thought I would just show it there. And I have no idea why this is here. So it's in the playground. So let me, I can click anywhere to add a swatch and I can change its color. So let's say we try and make it nice and yellow here. And this one, I'll make it blue, for example, like this. And so if I want to see what these colors will look like in a gradient, I can simply glue them together. And here, voila, I have a gradient. And maybe this blue color is not quite producing the gradients that I would like. So I can quickly open up the neighboring colors and experiment and see, oh, is this the gradient that I want? So let's say maybe I go somewhere here. And I can also add more colors and change their color and create more gradients, and also quickly visualize and get a sense for what this would look like on any input SVG design. And I can also share this, save it, and share this link with my friends or collaborators, say if you're working on the same figure. So I don't know what's next for this project, but it feels good that it's launched. So if you have some ideas, please reach out. So in this next work, I try to move away from just designing interactions to actually figuring out what representations for color would work well together with AI. So this next project is in collaboration with Alain, Sanya, and Karan. With Playful Palette was nice in that it was a compact representation, expressive, but it was unstructured, and it was, although there is existing work, but it is a little bit unwieldy when applied to existing colors made in some other software. And Color Builder was also intended to create palettes for new artwork. With color triads, we tried to create a representation that works to model existing color distributions. And the key observation is that many natural color distributions, like this grass here, with colors plotted in RGB, can be approximated by a nonlinear RGB triangle called the color triad. And then we can approximate all the colors in the image using colors in this parametric representation. This can be useful for a number of applications, for example, recoloring, and also deep learning, compression, and more. At the start, we ask, what's the minimal interactive primitive for modeling common color distribution? Key is it's interactive. You can actually change the color distribution. So if we look at a shaded object, well, if it's just a flat circle, it's a point in RGB. If it's a Lambertian sphere, it's modeled by gradient. As soon as you start adding specularity, the distribution begins to resemble the span between the specularity, diffuse color, and the darkest dark. And of course, there are a lot of nonlinear color effects in nature, as well as in painting media and so on. So it's not sufficient to just model this as interpolation space between three colors. So with color triads, we're able to model both linear and nonlinear distributions. And so on the right, I'm showing an approximation where all the colors are coming from the color triad, which has very few parameters. And these are very, very close. To convince you that they're not the same, you can see that some of the brightest yellows in the bottom sphere are missing on the right. And color triad is just parameterized by the 3 vertex colors. This is what standard RGB interpolation would look like. And in addition, it has this subdivision parameter and 3 parameters B, PU, and PV that control nonlinear blending behavior. It can also be easily plugged into deep learning architectures, for example, to approximate complex colors in an image using several color triads that can then be used for editing. Color triads, surprisingly, can also model colors. Just a single color triad can model colors in entire images. So here's the original, and here's the approximation only using colors in the color triad. So as you can see, it's very close. The banding artifacts in the blue image are expected because color triad is discretized. So the link that's established between the color triad and the reconstruction can be used to drive recoloring. I can change the color triad parameters and so recolor the image as well. And the demo of that is available on the same website. So for example, I can change the red vertex parameter to blue and recolor the sphere. I can shift the focus more towards the blue, which is part of the nonlinear parameters, change the highlight and adjust the blending to be more on the greenish side, creating this very natural change that's quite complex. So what next for color triads? Well, there are some applications, for example, AI-assisted recoloring of regions where we can learn, well, semantically, which parts of the image are likely to be recolored together. But it's also more generally useful for GL, and I'm actually using this representation in some of my ongoing projects. So I talked a lot so far about designing for interaction, where we try to think, well, what is needed for this domain and what interactions can be designed? And then I start thinking about representations that can be useful in machine learning, that are more structured, that you can plug into deep learning architectures. But what happens if the tools we want to build require intelligence that doesn't yet exist? Well, we have to switch gears at this point and really try to develop this intelligence. So if we all look at these images, they resonate with us. Even the very, very abstract Picasso, right? We know what they mean, but computers do not know how people see the world. And they must be taught if we're to make our design applications smart. So computer vision for realistic images has made remarkable progress, not just for recognition shown here, but generation and video, you name it. But even something that's simple for modern networks, they still struggle to generalize to stylized content. And that's something that's largely unsolved, although that's starting to change, but there's a long way to go. So if we want to make really smart software for creative tools beyond drawing and animation, also for communication and so on, we have to develop these smart algorithms. So my thinking is that, well, we can start with a specific application. And for me, it's 2D animation. So while it's relatively easy to draw, like I can draw this penguin, anyone can draw a stick figure. Animating it is hard. And so you can imagine how this drawing can move, but why can't a computer do the same? There's been a lot of amazing work on animation, but the problem is much of existing software, images are stupid. All images are treated the same. So it's painstaking to rig and animate them and to keyframe them is really hard. We should aim to build systems that incorporate prior knowledge about the way things move to make these creative tools better. And luckily, we have a lot of animation content out there in beautiful styles, expressive, abstract. But the problem is that even low-level vision algorithms still fail on cartoons. Like if I animate this little cat here, and I try to use a standard optical flow estimation method, it's going to produce garbage. And that's a problem, because if we wanted to learn something about, for example, motion priors in cartoons, well, we don't even have the basic toolbox available. So in this next project in my PhD, I really build up a prerequisite for creating intelligence. And this is Creative Flow Dataset in collaboration with Ziheng, Amlan, Jiaman, Angad, Karen, and Sanyam. And so the motivation for this project is to encourage more research on computer vision for stylized domains. And it's the first multi-style, densely annotated, non-photorealistic video data set that has ground truth, flow, segmentation, depth, normals, and more. And it's large and it's available. These are all the styles that are included in this video data set. Thanks very much to the GGP lab for helping me collect these styles. And this is what it looks like. So it's synthetic. It's these 3D characters rendered in non-photorealistic way using Stylet by Fisher et al. And it has all these dense annotations. So the goal is that using this data, we can start learning low-level vision algorithms that will enable us to analyze cartoons that already exist so that we can build better tools for animation. But it's a really big project, so what I can make is really far removed from what we should aim for. So I really hope all of you and many more people who are not on the call will be working on this. So if we build intelligent agents that are able to, for example, predict some sort of motion, we have to look back and ask, well, what kind of interaction is actually needed? And only by going back and forth between these intelligence-first approach and interaction-first approach will we be able to build new tools where intelligence and interaction truly go hand in hand in order to support human creators and their creation as a process. Before I conclude, I just wanted to share a few findings about what it is important for designing for creativity as a summary. This is basically what I found out in all of the projects I just described. If you're designing a creative tool, it needs to support exploration. It can't just present one option, and playfulness. It should provide immediate feedback. And activity should be perceived as intrinsically rewarding, enjoyable, i.e., build tools that are fun so that you feel more creative using them. It makes sense. But it should also provide a sense of challenge, the feeling the potential to succeed, and also a sense of control. Much of this comes from the psychology of the state of flow. And so these three aspects are often overlooked in interfaces that are so quote unquote built for creativity. And I have also failed to add them to some of my prior work. But in my more recent projects, I have tried to make sure that there was a sense of challenge and potential to succeed and control as well. Another important point is whether or not you're designing for a professional or a complete novice, the requirements for creativity are the same. Even this little girl needs to have a sense of challenge. She needs to feel the potential to succeed, and she needs to be in control when using the interface. And looking at my 2-year-old, I can definitely say the feeling of control is important. So how do we design this? Well, the best advices I have is to look to creators for inspiration as often as you can. So if we think about this, if we could build really anything with any kind of intelligence, what is an ideal interface? When I started this line of research, I thought it was this. I thought, well, I could imagine what I wanted to make, like an animated film or movie, and the machine would just build it. But actually, the more I work on this, the more I know it's not true. It's in the process of making that you actually discover what you want to build, because creativity is not a single road. So you have to create interfaces that allow one to take many paths, because the path itself matters. You don't know what you will stumble upon along the way. And I would like to thank all the people who have helped me on my path to get to do the work that I actually really, really love. So my mom, Nadia, and dad, Alex, my grandma, Valia, my amazing partner, Dave, our daughter, Yana, and Sima and Tanya, who stuck with me along the way. I'm also really grateful to Karan and Sanya for being the best supervisors I could possibly wish for, and to all the people who have helped me in my career. I'm also really grateful to all the places I got to work at during my PhD, especially the DGP lab at the University of Toronto, as well as to the financial support from the Canadian government, and to the Vancouver Foundation NGI for this award, and to the audience. Thank you very much.
Thank you very much, Masha, for the excellent talk, and congratulations once again on the award.
Thank you.
We received a few questions on the YouTube chat. Actually, a remark first that I would like to convey from Alex Jacobson. His opinion is that what you described as the fail to materialize as a product is not a fail at all. The work is very inspiring, and he loves that it's possible to unmix colors. So I thought I would convey this remark along. And a question from Daniel Ria and Eugene Freeman actually related. You started out mentioning digital art can be unsatisfying. And I wonder how artists raised on digital tools feel about real paints. Do they have different issues with modern art software? Is there something about the physicality of real art as opposed to digital software that plays into expectations?
I think it could be about that. I definitely saw a lot of hesitation to use digital tools in the physical artists that we worked with, but I also think there is a new generation of artists that maybe even like the mechanical nature that can exist in some of the widgets. So you have to be really careful, and it's difficult. Designing for all of these people together is really difficult. So I think ultimately you have to present two ways of doing things, right? If I create this really free-form palette that speaks more to the, tactile and physical interactions, I have to still keep the traditional digital color pickers in place. But I don't have a single answer. I think it's really hard designing for all the creators out there, and you just have to go and speak to all of them. Well, a fraction of them.
Yes. And I believe, Kelly, you have a question as well?
Yeah, you mentioned that AI is not very good at understanding cartoons. And I wondered if you could comment, because there's a lot of studies I'm aware of that cartoons rely on caricature. So they essentially exaggerate the essence of something. And so for humans, we actually recognize cartoon characters, or caricatures at least, as being in some sense more like whatever it is they're supposed to be than the real world. So this is almost like a disconnect, that AI has a lot of trouble doing something that humans do very easily, which is take something that's not a realistic representation, but know what it was intended to represent. Do you think there's any hope for that?
I think there is, actually. Looking more and more at the ML community, I think we will get there, because basically now a lot of the deep learning models, they overfit to the fine textures because they see a lot of realistic content. And so we need to teach them what those important features are somehow, right? So maybe if we train something that is supposed to recognize a cartoon tiger as well as the real tiger, it will start to understand what we as humans, using our unique brains, consider as key characteristics. Because maybe if we were some aliens, our caricatures would be like really precise textures. We don't know, maybe, but we're humans, so we take a different stylization, in our thinking.
Well, and when we look at a political cartoon, we're almost always interpreting in the context of current events. So that gives us clues as to, which politician is being ridiculed.
That's right. There's
it's a much more constrained problem.
Mm-hmm. For sure.
So I was wondering if you look at usually the end results and you want to learn from what you started with, and then you end up with the results afterward. How much of the process itself, just like the frustration, the failure of an interface, can be useful in order to design something, or to help us to figure out that this is not the right way of doing things? Do you have any experience?
I mean, I think ideally this should happen all the time. None of the research projects are complete. I mean, of course, you do a user study and you show that it's promising. But with Playful Palette, for example, some of the initial interactions that we had even tested in our user study, we redesigned later. Yeah. And I think if we were launching it onto a product, it will be a few more iterations to get it right. It's the same with what I have currently online, because some people commented saying like, look, I work with a lot of constraints. I work with companies, they have a set color scheme, like I can't deviate from that. I also need tools that constrain me. Mm-hmm. They can't be just free form all the time. And so I think it's always a process, and it's never done.
Yeah, that's the wonderful part of it, because that means it's open research, and we still have many problems to solve.
That's right, yeah.
Great. Wonderful work. Thank you.
Thank you.